Hi, my name is Richard Langlois. Today we're going to do a demo. I'm going to take an application that is a legacy application. What I mean by legacy application, I mean a database that is updated by an application, as simple as that. It's not an event-driven architecture. So when you have an event-driven architecture, you have a database that is updated. You also an event store that is updated, and you produce multiple business events as any change is done. Why we need that? Legacy application suffers from um, usually having the last changes kept in the database. All events are not necessarily captured in a full history transaction database type. And that's a problem. If you change the price multiple times, you may, it depends on your database, it depends on your application. You may only have the last price as of today. You may not have if you change the price 3 times because you're doing some A/B testing. When you have event-driven architecture, any change you do independently of your database is going to end up in an event store. It's going to end up in the lakehouse, and it could be used by any other application that are essentially subscribing to those events. What I'm showing currently is a dashboard. Um, the lakehouse uh, is made of a bronze, silver, and zone, which takes those events and reorganize them into an integration zone that is called silver and a gold zone that is consumption. And then it's being replicated into a serving layer on which you build dashboard. So the dashboard I'm showing right now just show you that some customers, multiple customers, have placed orders, and these are real one with their head office there. This is not fake, but all the rest is fake. All their orders is fake. Um, their credit limit is fake, and so on. I just want to make sure we're clear on that. And with the product, it's a bit similar. If I was to choose product here, now you have the product name. Those are real products, but not necessarily the exact product. I took some liberty with the name, but they are based on real product. But the rest, price, and so on, also fictive data. So let's be clear. This is a demo platform. We are selling the source code for all the platform I said. It doesn't mean that all our products are source code based. For example, the event registry and the data governance platform are binary license, but the one I'm talking today are source based license. Why? Because this is a reference architecture with working code. And the reason why we're selling that is that you can then mimic, take the code that we did, adapt the pattern that we did, and then you can transform all your legacy application into real-time application that are event-driven, as well as intelligent, meaning they consume your AI models in real time. So the inferences, which is running AI models, are sent back into the something we call the EDA platform, where those are events, and then the application can act on this. We made a rule to not change your legacy application. So what we do, we use components around your order system, for example, or any other system, your CRM or your MRP or whatever. We put stuff around those systems that will intercept essentially all your database transaction and will create events from it. Technically, we use something called change data capture, and we use something we call BEC for business event constructor that will take the rough output from the CDC and will create real business events. The inference generate AI events. So this is how all these events are created. So The EDA platform is in fact something that allows you to manage all those events so that you can publish them and consume them. As simple in quote as that. Now, when you have both working, your application becomes smarter and real time. They are smarter because they can take advantage of AI. Okay, what's left to be said essentially is okay, how is it possible to not modify the legacy application? I told you that we are able to intercept the database transaction and generate events with it using the CDC and the deck. That's one thing. We also have a populate event store processes, one for the AI events, one for the business events. So they also take care of creating the store. So far, so good. We are now having EDA platform, right? So we took your application and we made it real time. Okay, but how to make it intelligent? We have created what we call legacy EDA extension. What are those? We have one, for example, that will do threshold processing. If you have AI inferences, and in our source code we have two, we have one that check for fraud, and we have one that check for anomaly. We have an order system so that we can generate events so that you can test all of that. So when the inference are run, it means that score are produced. What's the risk? What's the risk score of a fraud? What's the anomaly risk score of an anomaly? Right? So this is simply scores. Those scores, we create AI events with them. So it's back to the real-time platform, right? The EDA. Now, in order to take advantage of those, you then need to have a threshold validation module. The threshold will check that those scores are below the thresholds. If they are below, the application would let go in our case, the order. So the order will be placed, uh, technically place approved because it's approved because it's under the threshold. Now, if it's above the threshold, the EDA extension will create orders that are placed on hold. Another extension will allow a user to review these placed on hold orders and simply will approve or reject them. So you see a threshold module followed by an approval module is what we add around the order system. If it's another system, it's the same approach, threshold and some approval mechanism. Okay, so that covers that side. So it means that you can now intercept in real time in any orders that may be fraudulent, right? They could be a fraud or not. Again, it's all about threshold. It's all about understanding what's the right threshold for your business. Okay, so that's how we do all of this. So why am I showing a dashboard? It's because all those events will also populate the lakehouse. The lakehouse is made of multiple pieces, by the way. There is the batch zone. This is where you have the bronze, the silver, and gold. This is the integration of the data. That data is used to do machine learning and retrain your model, your AI model that you may acquire from somewhere else. But you need to train on your data so that the scores are as precise as possible using your own data. So the lakehouse is where you store the data so that you can train your model or even create brand new model. It's also where you can use this as for your business intelligence, and you can also use it for operational research. We provide a strong foundation. That's why we build a lakehouse. But the lakehouse has what we call the AI speed layer. This is to run these models. Once you have a model that has an AI model that has been uh, stabilized, solid, you deploy it. When it's deployed, you need to make sure you can run it in real time so that you can then do the rest I said. Score them, send the scores back to the EDA platform so that your application. By the way, if you have native EDA application, it will also work. And our application we provide is actually a native application, but we put the switch on it. So let me show what I mean by that. So if I go in the order system, if I go here in the EDE mode, you see that currently the mode is in CDC. This means that when we do that, the application will not write to an event store, and the application will not produce business events, right? Like a native application. If I want to change that, I can show here, and I can switch to direct EDA. But if I do that, I'm kind of simulating and doing a demo on something that is already native. So I'm leaving this in the CDC mode, meaning the Bayesian will be running, the BEC will be running, the event store populate process will be running. I've also have this thing here, which means that the order system will be listening to check the threshold of the scores produced by the AI speed layer. Again, in a real application, you won't do that there. You will do it outside. For the sake of a demo, we've put all into the order systems directly through tabs, but you need to understand that each of these tabs could be legacy extension, right? So that's one thing to understand. So the threshold simply means the order system is going to validate the AI events produced by the inference. What else? The event log, this shows the content of the event store. Being direct or being in CDC mode, that they end up in the event store anyway. It's just that the mechanism is very different. If it's a native ED application, it goes straight. At the same time you create the order, it also creates the event. But when it's done through the CDC, it's going to go through the CDC, the BEC, and the populate process. But all of that simply add about a few half a seconds of average. So that's the thing. It is real time. It is quite fast. Um, and then you have something else that if you have inference, then you may have orders that are above the threshold, and therefore they need to be reviewed by human. That's what this screen does. So again, imagine this is something on the side around your order system, meaning that somebody can review. It also means that we are adding what I will call business event to your order system, your CRM, your MRP, your financial system, whatever is the system. We are adding event type to be precise. That's the only way we can do that. So we will have additional event type to manage this, and so that the people will be now having a more a richer environment. We also make the lakehouse smarter because the lakehouse can also consume all the AI events back into the batch layer. What I just said here means that I can do models that will take in consideration scores of other models. So this is very powerful. So now I have more events in the lakehouse, right? So I can track mini change of price during the day, as I was explaining, or customer credit limit or whatever, meaning that there are many use cases when you can do that. And then I also have all these scores, these predictions done by AI models. So it means the lakehouse is more intelligent as well, meaning your model will be more intelligent, so you will do a better business, right? You will meet customer expectation, employee expectation. You will improve your operation from all angles. Talking about that, go to our website, the IT architecture and strategy.com website. We've put 16 industry use cases about these flows of events. It totally changed the game. We're very excited about that. So now what I have to do is simply run transaction in front of you so you see. I also put some compensation mechanism in the lakehouse. When things are broken or when things change, even the lake house or the way that people build those, they will override history. We don't. We never do. We use compensation, which is like doing what accountants do, what's called reversal. So if a transaction that was fine yesterday and you make decision based on that yesterday, but today that it's not the case anymore. So you don't eliminate that transaction and make the people who make the decision based on the um, understanding of the data as of yesterday look bad. We are actually reversing it and creating the new transaction. It means what? It means that you can have the data as of yesterday and the data, the same data as of today with different numbers. And that's important. So it's more than slowly changing dimension, which is your axis of analysis. This is a full audit of all your matrix. And one way to explain that, if I switch back to Lakehouse, if you see these here, you will see something to receive, and same thing if it's requested. As you can see, these three don't have any data. The reason why here there is data is because Bank of Montreal and National Bank were on hold for some of their orders, but when they were approved or rejected, as of today, there are none, and it represents nothing. But it does still tell you that those were the customer who had some orders that were placed on hold. Today, they are placed or they are rejected, one or the other. Because think about it. If you run your lake house every 10 minutes, right? Because you can. This is all real time. This is not, we run the lake house once a night, like mini lake house are done. This is real time lake house. So if you do that and the human didn't approve or reject, you will have a case, and this is perfectly normal, where some orders are still on hold. This is good. So if you don't have enough staff, or if some people are sick and they are not doing the job of approving or rejecting orders, you now know the value of those orders that are on hold. It's much better than having fraud this process. So if it's under threshold, no issue, nothing's changed, the orders are placed. But if the risk is high, then a human may decide if it's okay or not to let an application go. The example here is that if I order 50 heat pump, this is more than $500,000 order. It may be valid or not. It all depends who's the customer, if you know the customer, and what the customer is doing. Okay, I'm done with the talking. So now I'm going simply to create some transaction. Again, this is in this system, the order management system. Again, the EDA it's off, right? So it means this is like an old system, an old application, what I call legacy. A legacy application only update a database. This is what it means. The threshold though is on. So even in that mode with your legacy, I will be able uh, to use the inference to make your legacy application intelligent. To make them real time, that's simply because with the CDC, the Bayesian, that's the name of the CDC product, and the BEC and the populate store, it now behave like a native application. Again, the latency is an extra 0.5 seconds roughly to do all of that. Okay, so I said I was going to do some transaction. Let's do some transaction. So if I go on customer, what I can do on a customer, let's say I take Best Buy for example. They have a credit limit 70,000. I'm going to put it at 71,000. Sorry, I'm updating this, so you see it's 71,000. But in the event log, uh, I'm going to refresh the event log, and you see the customer credit limit has changed. Interesting, right? So it means that even if this is now like acting like an old application, the um, the Bayesian and the Beck created and the Play Store did all those three components made it behave like it's an ED application. So you see, That's the thing. No change beside the three pieces I said. Uh, Now, if you want uh, to have the proof of that, I have a much longer video that explains everything I said. I'm going in Kafka. I'm showing the topics content. I'm looking at the database. I'm looking at a bunch of things. I'm showing terminals so that you can see that this was all done. In the interest of keeping this for non-technical and keeping it much shorter than the other one, which is more than 55 minutes, or 54, I think. Um, this, I'm going straight with the result. Okay, so I changed this. What else I can change? If I go on a product, if I take anything, if I take here tune, GBL tune buds to whatever, it's 139.98. I'm going to make it 138.98. I'm updating the product. So that's also a change. And I'm going to go in the event log. I'm going to refresh, and you see the product price has changed. So you see this is what you get. The bud, I forgot to show you the bud where I forgot the name. Here, the bud. So 138 and 99. Okay. So this is what we're doing. Now I'm going to do an order. Again, I'm playing with fictive data. The name of the companies under location is real, and the product, the names are close to real one, but all the rest is fictive. So when I choose a customer, for example, Fabricville, um, be, which will have rejected orders because their credit limit is low, this is artificial data again, right? So if I go here, I show you Fabricville. So they have a 5,100 credit limit. Okay, so I'm going to use these guys. So I'm going to do an order that will have a credit limit uh, exceed. So let's do this, Fabricville, right here. So I'm choosing something that is expensive, choosing an e-pump. One of them is enough. So I'm placing the order. The order is rejected, as you can see. If you go in the event log, the order was requested, and the item was priced and rejected. Then the sort here, if you have the same time, it's sorted by timestamp, and that's why it's reversed. But if you look at the ID, 42 is at the end, rejected. Okay, having said that, now I need to do an order that will work. Okay, so I'm doing an order for, I don't know, let's say Air Canada. I'm going to take, yeah, let's take some Alienware. I'm going to do 3 Alienware, and I'm going to add something else, Apple 2 to have a different number. So I have these two, and I'm going to place. So the order is being placed, Air Canada. It shows received, which is the first status um, before the inference work. Now I'm going to refresh, and as you can see, from requested to receive, the two items were priced and it's placed. Going back here, I guess you will see that the order is placed, right? I guess I knew. So anyway, so this is as you can see, it's extremely fast. It does the job. Now I'm going to do two orders that will be placed on hold because I'm ordering a lot of heat pump. So and I'm going to choose two customer that have very large credit limit. So it's going to work. So I'm taking Bank of Montreal. I'm taking a heat pump here, but I'm going to put a lot of heat pump. I'm going to put 50, yeah, 50 heat pump. Let's do that. And I'm going to place it. So it's received. If I go in the event log, it's going to show it's on hold, right? Receive one item price, and it's on hold. I go back here, it's on hold. Now I'm going to do the same thing. The goal is I'm going to approve one and reject another one. 50, I'm going just to make it different. 49. It's still going to be placed on hold. As you can see, it's received, even log. Go back here and I have the other one that is now on hold. Go back here, national. So you see I have two on hold. If I go here, you see that they are there. If I click, you see the detail. I could approve and reject. Now, I'm not going to do it in front of you now. I could, but I want to run the pipeline so that the lakehouse will be updated and there will be two order items that will be on all. I want to show you that so that then I will approve them and reject them, and then the place on all will be back to 0. That's the compensation in action. I'm going to show you that right away. So now let me switch. Let me switch to this. Here, essentially, those are terminal. This is all running in Linux. So it's Ubuntu on my machine. So this one here is the OLAP, right? This one here is the speed layer. This was to simply say, hey, start the inference. This one is the EDA platform. This is where I created the transaction I did with you, right? It's a long one. I was doing other things before I did some change. My point is, this is the terminal of everything that was done today. And this is where I run the pipeline. So this one, I'm going to do, in fact, I'm going to type the same thing. So I'm going to run this. And when I do that, before I do that though, let me start another terminal. By the way, in real life, all that is done this way. This is done in a demo, but it's a real demo. So now why I'm doing that is I want to show you that it's running essentially. So I'm going on the Lakehouse platform. If I can type right, that will work better. And what I'm going to do is I'm simply going to do a tail so that you can see this working. And I guess I did a typo. Yeah, I'm missing G. I'm going this. So this was the previous pipeline I did before the presentation and before the demo I'm doing. And now watch this. I'm going to start this. So now the pipeline, as you can see here, let me make it bigger. The pipeline now is started. So a bunch of PySpark jobs will essentially take all the events I just created in front of you and will bring them into some S3 object storage. Sorry, I have to put some technical here, but it's going to store them. And then more jobs are going to process that to do the integration with full history in the silver zone. And then when the silver zone is finished, there will be a bunch of things that's going also to be done to reorganize that to create what we call a consumption model, which is based on a Snowflake dimensional model. Not the database company called Snowflake, but the Snowflake schema approach, as defined by Kimball more than 2 decades ago. We've been doing that for a number of years. We actually do what we call denormalized Snowflake. It gives more flexibility in terms of um, creating a constellation of Snowflake. I'm getting a bit technical here, but the point is it makes the model very adaptable to any other matrix you need to add. Therefore, you can produce a bunch of ratio. Most companies cannot do that. In order to do that, you need to do a constellation of snowflakes made of confirmed dimension. And why denormalize? So that you have the gain of the star schema, which gives you performance. So we are doing denormalized snowflake for performance, and the adaptability for having what we call a dimensional enterprise data model, meaning the entire enterprise can have all their matrix fully integrated. Not many companies do that. In fact, um, in my more than 4 decades career, the only company that I saw doing it are the one I've done it for them. Most companies do not do that, unfortunately. And therefore, it makes their analytics, it makes their report, their dashboard, makes it a bit difficult to use across department. I will use that term. Okay, so this while I was talking, the bronze was done, the silver is run, meaning that we're creating the integration zone. In terms of the speed, this is important. Starting those jobs is heavy, um, meaning that if you put them on big server, not a laptop like me, it will be faster. And you will have much more transaction than just the small number of transaction I did. And it's okay because starting these process is expensive, but once started, the processing itself is done fast. It's also PySpark. It means what? It means that parallel processing is possible, but parallel processing when you're running on a laptop is not that good. But the point is, it's super fast. And if you heard the company Databricks, they are the one who invented Spark, and in their implementation today, they still use that. They also use Delta Lake, which we also use. Therefore, we're PySpark and Delta Lake, meaning that if you're a Databricks customer and you want to convert all your legacy application to make them real time and make them smart by using AI, you simply use our source code under your Databricks software, and you get the support of Databricks, and you get additional feature that Databricks offers that in the open source that I took, I don't have all the features. I have plenty though to build something great, as you can see. But Databricks have some additional features that you can gain. So it's either you do this on your own, and by the way, this is now finished, and it also creates the serving layer, which replicates the gold into a low latency database. And I'm not going too far there because if I do, I'm going again to go too technical. So I will switch to the other area. I was on the other system. Now we're going to go in the cube. So if I was to refresh now, you will see that it goes by default to place and so on. Now I have more orders than I used to have that are place. I have more quantity. If I go on place on all, I have two. And you recall I've put some quantity 53 and 52 something. I don't recall what I put. I guess I put 44, 45, something like that to bring it to 99. So I have an extra rejected because of the credit limit that was exceeded. So now I have 9. I used to have 8. Um, and I don't have more here because they are on hold. So we're going to see. And if I'm back to the place, so taking this, I guess the way to show you what I did, I will show some customer, some product, and I will show day. I will sort by today. Today I did many things, but if you look at the last transaction I did in front of you, I did transaction with Air Canada, Boeing, I think. So that's what you're seeing. So those are the one I did now. And again, the place on hold, which is the easiest one to recall. Let me go on the place on hold. So I have, yeah, so those today, earlier I did test this again. And I have the 49 and the 50. You recall it was 59. So those are two order items representing 99. So 2 and 99. Now, I'm going to simply switch here to the order system. I'm going to approve one. So Bank of Montreal, I'm going to reject it. Okay, why? Because look, it's so first you see it's on hold because look at the score higher than the threshold. The threshold could be changed by the way, so this is based on your company. Okay, so this guy has been rejected. So if I was to go here, it was on hold. Now I will have it rejected. I go back here, and if I click that guy is National Bank. I'm going to approve it simply so that we have. Now I don't have anything else here. The orders, as you can see, has been placed and rejected. And the here is going to say the same thing. The rejected, that was the Bank of Montreal, and all the place, this is for National Bank. Okay, so you got the demo. That was my goal. I show you all of that. Now to the lakehouse, the compensation capability of the platform. So now I'm simply going to do another pipeline, right? So I'm going to reprocess this. So here I'm doing that, and bang, it's running. It's here. So you see the pipeline is restarting. I've done one, and another one is being done right now. So I will let it run. It's about short. Okay, so I'm talking now. The last dimension is being done. This is an order system, so the order itself is a dimension. The dimension have a status. As you saw, place on hold, receive, and so on. Those are status. So I have the full history there with, again, a slowly changing dimension type 2. Sorry, I'm doing it again. But it means we have a full history on the dimension, and we have the full history with the compensation on the matrix. So you have the entire history, nothing. This is your this is fully auditable, unlike 99% of companies. They say it's auditable, but it's a long process. In this case, it's not. Okay, so you see we reach a complete. Now I'm switching back here. Now, if I do a refresh, it's going back to the place, as I said earlier. So I think there is one more, right? Because National Bank was accepted. If I go here, now we're back to 0, right? So that's why it's great. It goes back to 0. If I go again with the individual customer, well, it was these two guys that did huge orders that were flagged. Again, the reason why it's flagged, it's because this I use AI models that were done somewhere else, trained on some other people data. And since I only have fake data, I cannot train them better. What I do though, I create a big order that looks real strange, and therefore both risk or score high, they are being put on hold, which, as you saw, I have approved one and rejected one. If I go back to the rejected, uh, now we have one more in the rejected, so I click here, and as you can see, I now have 12. Anyway, so this is what we mean by having a more, take your old legacy application, make them real time, and make them intelligent. Since we now use AI inference, and I also show you how to create lakehouse that are richer, full history. Now these models depends on doing great CDM, conceptual enterprise data model, and DEDM. We have 4 decades of experience, a huge amount of CDM done across industries. Same thing with the EDM. Therefore, we could create something extremely sophisticated for you without you guys being forced to change your operational system. That's the part that is amazing. We are not changing a single line. We are adding around your legacy application, and we are applying the patterns that you saw. Thank you very much. I hope you like it. So this concludes the demo.